Chirality in the genius of creation. Naturalists, evolutionists, and atheists insist that stochastic processes of creation are fully capable of creating the human DNA and its minimum ability to encode about 750 megabytes of data per cell, or about 215 million gigabytes per gram of DNA. That's called petabytes. For reference, our best silicon chips can achieve about 466 gigabytes of data storage per gram of silicon. Even if stochastic process supporters could remotely propose a mechanism to try and claim this information density, the specific details would form an insurmountable bar to demonstrating those claims. And why? Well, one reason is the chemistry of chirality. Now, what is chirality? Well, in organic chemistry, chirality describes a molecule that cannot be superimposed on its mirror image. And what the heck does that mean? Well, look at your two hands and place your two hands in front of your face, palm facing palm. If you hold up your hands in front of you like I've described, you will see that they form mirror images of each other, as if either hand was being reflected in an actual mirror. But if you place your left hand over your right hand, they do not match up. This is chirality, mirror images that cannot be superimposed upon each other. The same thing happens in organic chemistry, which is the chemistry of life. We often hear that life is carbon-based. That means all of our molecules are based on carbon. And carbon has this neat ability to attach to four other things, be they atoms or groups of atoms. For example, look at hydro, fluoro, chloro, hydroxy, methane. This is a carbon atom attached to three other atoms and to the oxygen-hydrogen atoms, which are called a hydroxy group. If you hold up two of these molecules like we did with our hands, you will see that they are mirror images of each other, as the enclosed figure in our video or audio images will show. Now, if you lay one molecule against the other molecule, just like we did our hands, and you match the hydrogen to the hydrogen, and you match the OH to the OH, you will notice that the chlorines and the fluorines don't line up. This is molecular chirality. And why is this important? Well, many of the chemical reactions in our body are chemically stereospecific. And a key example of this is digestion. The enzyme amylase in your saliva and pancreas specifically targets and breaks down starch, which are polymers of alpha-D glucose. Because your amylase only fits the stereochemistry of alpha-D glucose, you can extract energy from potatoes and bread. However, humans lack the enzymes required to break down cellulose, which is chemically identical to starch but uses beta-D glucose molecules to build up the cellulose. The consequence is you would starve trying to eat cellulose, although it is chemically identical to starch. The stereochemistry is all wrong. Now, why do we care? Well, in everyday nature, if we try to synthesize a stereospecific molecule, we will get a 50-50 mixture of both stereo kinds. Those are known as enantiomers. This is because ordinary laboratory synthesis processes are not stereospecific. Let's consider another example, ibuprofen, a pain reliever. It is formed as two stereoisomers. When we take a pill, roughly half the ibuprofen is useless to us because it is the wrong stereoisomer. The body can't use it, and so down the drain it goes. Literally, if you know what I mean. Now consider naproxen, an even better pain reliever. It also is formed as two stereoisomers, but one of the isomers is toxic to humans. Before it gets to you, it goes through a process called chiral resolution to remove the toxic-forming isomer. The pill you take is just the active stereoisomer, which is one reason naproxen works so well. Well, by now you might be asking, is there really a point to all of this? And yes, there is. It turns out that stochastic-based creation chemistry is just like the laboratory. It is not stereospecific. It cannot produce just one stereoisomer of a molecule. You will get the 50-50 mixture of stereoisomers, which is called a racemic mixture. Because of this, the idea of complex bioactive molecules crawling out of the muck of a Louisiana swamp has the probability of zip, zero, nada. And God wins again.